So in this video, we are specifically going to now look at a format that our non-proportional equations had come in. All right, so we had talked about non-proportional relationships had to have the equation y equals mx plus b. All right, and that's all fine and great when somebody tells you what to write and what to look at and what to focus on. So today we're going to kind of take that equation up a notch and kind of explain the pieces and the parts that are entailed with it. All right, so let's go ahead and write slope-intercept form. All right, and we're going to go ahead and kind of write what slope-intercept form entails. All right, slope-intercept form is a way equations are written to give you both the slope, which is the movement, and the y-intercept that crosses the axis of a line. All right, so our focus is going to be interpreting what this story, what this line, what this creation actually means. All right, so there's two parts of it. We have our slope, which is the movement that's taking place between the data pieces, and the y-intercept is where it starts, that phi, those different things. So yesterday we kind of started talking about this when we were talking about non-proportional relationships. This just takes it kind of a step further. All right, so we need to kind of go ahead and jot down to ourselves what this format actually is. And the The slope-intercept form is y equals mx plus b. And I purposely drew it in bubble letters and used my colors because I want it to stand out, because we're going to be using this format for quite a long time with what we're doing. So we want to make sure we understand all of the pieces and the parts. Okay. All right, so now let's focus in on what each of these people mean. All right, these letters mean. So first, just like in proportional relationships and y equals kx, x represents the input. It represents the number that is going into the story. In our equation, x will always stay x. Okay, x does not change to a number until we are actually solving. All right, just like x, y is exactly the same. Okay, y is by itself on this other side of the equal sign, so that makes him the output. All right, so this is the answer that we get. We plug a number in, it gets multiplied, it gets combined, and then we get our answer. All right, so let's talk about these new pieces. All right, let's talk about the new pieces. The first new piece is the letter M. The letter M, okay? And the letter M, in this case, stands for slope. Now you're like, wait, what? That's an M. Well, yes. One of those definitions that they tell you is they tell you that the slope is the movement. And so we can use the M of movement to remember this M. All right, slope is the constant between values. All right, slope is that consistency going through it. It is the unit rate that is occurring, okay? And it is still the change in y over the change in x. Okay, so you need to understand that this little letter, this M, represents all of this. It is the constant, it is the unit rate, it is that rate of change, the change in y over change of x that gets applied to the values. It's my hourly rate, it is the price per apple, it is that single value that is consistently being used over and over and over again, which is why it's getting multiplied to that x. All right. So now let's talk about B. Again, an arbitrary letter that they kind of threw in there. All right. The B is my y-intercept. The B is the y-intercept, which is what where I cross Okay? The y-intercept is where the data crosses the y-axis. The y-intercept is where the data crosses the y-axis. All right? What you also need to understand is that represents the fee or the initial cost or any of those first starting values. Okay, so you need to understand that in this equation, these little old letters represent so much more. So today we're going to be focusing on building the equations, and then we're going to start talking about interpreting the equations and how that all works. All right, so let's go ahead and we're going to start kind of with the beginning and just identifying and pulling information from these equations. So we are going to identify the slope and the y-intercept, and we're going to take the sign with the number, and that slope needs to be written as a fraction. So understand, if it's a whole number, it's over 1, okay? So in terms of pulling slope, we write it as a fraction, but when we write it into the equation, we write it as a whole number, all right? So let's take a look at a couple of these problems. All right, so we have this problem here, y equals 3x plus 2, okay? Now, if I wanted to, I can go ahead and I can write the slope-intercept form right on top of it. I could write y equals mx plus b. Some of you guys might need to do that so you can visually see what number stands for what letter. So I want to know, all right, I want to know what would be the slope, which is m, and what would be the y-intercept, which is b. All right, so I want to know what are these numbers that are getting pulled from these equations when we look at it. Okay, so if you notice, b is paired up with this positive 2, and you'll notice that m is paired with the 3. Now, please understand that we do not steal the x with it. It is just that 3. So my slope in this case would be 3 over 1. My y-intercept in this case would be plus 2. So again, I'm stealing the values as well as the sign that goes along with it. Okay, so let's take a look at another problem together. All right, here we have y equals 2/3 x minus 4. Okay, so I want to know what is slope and what is y-intercept. All right, and so again, we're going to steal these values from the equation. All right, so what would be my slope? And again, remember, slope is in front of the x. So in this case, the slope would have to be, 2/3, because again, it's in front of it. We don't include the x. X is input. I would just want the value of the slope. What would then the y-intercept be? All right, the y-intercept would be the -4. Okay. My kids are eating Pop-Tarts, as you can hear in the background. All right, so let's take a look at 2 more examples. And I'm going to actually have you do these examples, but I want you to think. They're purposely a little bit trickier. All right, first thing is we have y equals mx plus b. So, what would b have to be? And again, here, understand any number in front of the x has to be the number 1. So I'm curious, what do you get as the slope and the y-intercept for both of these problems? So let's go ahead and take a look at what you got. All right, the slope, we should have stole the whole fraction. So we should have sold -4/5. All right, and the y-intercept, notice it's gone. It's not there. So that means that my y-intercept would have been the number 0. This would have been a proportional relationship, y equals kx, because there is no y-intercept. That y-intercept is the number 0. All right, let's take a look at this next one. This next one, all right, we need to understand that this is one big fraction. So this slope would have been 1/3. And then this would have meant the y-intercept again isn't here. So it would have again been a proportional relationship of +0. Okay? All right, so that's just how we pull the information from equations. All right, if these were actual stories, these numbers would all have a meaning. Maybe it costs $3 per game of bowling and $2 for the shoes. Could be. All right, maybe I have cut 2/3 of the grass is worth something, but it cost me $4 to buy gas. So I'm already starting in the negative. So each of these equations tells a story. And again, we're going to get into that a little bit later. We just need to be able to pull the data effectively. All right, so let's go ahead and let's talk about writing equations from tables, because a lot of time they give me the information that way. Okay, pulling equations from tables has to be a literal sense of what we're doing. Okay, it is computation and calculation that goes alongside with it. All right, so let's go ahead and let's write down this table. Okay, let's write down this table. It's the number of phones that I'm selling. So if I sell 10 phones, 20 phones, 30 phones, or 40 phones. And it ties then to my weekly income. So I make $480 if I sell 10 phones, $630 if I make 20 phones, and so on. So apparently I'm selling phones. And basically they're telling me I'm going to get paid for just coming into work. But if I sell stuff, I make more. Okay, so they have set criteria. They've said if you sell, for every phone you sell, you make this amount of money. So that's what we have to kind of figure out. We have to figure out what is this equation tied to my work. Okay, what is the equation that's tied to me selling? So if I go and I'm like, oh, I'm going to sell 12 phones, how much money would I end up making with it? All right, so the first thing that we need to find out is we need to find out the consistency. I need to figure out how much do I make for one phone? How much do I make? So they tell me how much I make for 10 phones. They tell me how much I make for 20 phones. I need to figure out just one phone. This consistency would be called the constant, would be called the slope, would be called, right? They're all the same thing, all right? In table form, to find this consistency, we're going to do loop Ds, all right? And we need to find out how does this data change. So I am changing from 480 to 300 or 630. All right, my data has changed, and I'm like, how much did that change? So if I need to pick up my calculator, please do so. All right, and when I pick up my calculator, I have to do the reverse. 630 minus 480. How much did it change? Well, it changed $150. Boop, boop, boop. And then I sold 10 phones in that process. So how much did I make then? Well, I would do 150 over 10. And I would have realized that I made $15 for one phone in this instance. Now, again, I need to check this consistency. I need to make sure this works completely all the way through. So I sold 10 more phones. All right, and again, we do 780 minus 630. All right, and I made $150 again. So notice that consistency is still there. All right, and then last but not least, we find that last one, which again is another $150 and another 10. And I want to make sure I'm checking all of these. My daughter sounds like a teapot. All right, and I find out they all have that same consistency. So in this case, my slope would be $15. Okay, so to find that consistency in the table, we loop and we find out what is that slope. So every phone I sell, I make 15 bucks. Sweet. All right. But I also get paid for showing up to work. All right. Lakin, why don't you go upstairs with her? Go upstairs with her. I am teaching. Go upstairs with her. Okay. We need to find that starting point. All right. So to do this, there's multiple strategies that we could do. I am going to kind of straightforward just do the algebraic way because it's always going to work. Okay, but tomorrow and when we talk in person, we will practice the other formats as well. All right, so we need to figure out where it starts for y-intercept. All right, I need two pieces of information in order to do this. I need my slope, and I need one coordinate from my table. All right, so what I like to do is I like to make kind of a side table for myself, and I'm going to put m equals 15. And I'm going to put 10, 480. All I'm doing is I'm stealing from my table one of the values. Okay? And so what we're going to do y equals mx plus b. And we're going to go ahead and we're going to fill in all of these pieces. Okay? And I'm going to steal the information from my table. All right? We need to remember that the first coordinate is x and the second one is y. So the pieces that I've stolen are m, x, and y. And I'm just going to replace it. So instead of y, I'm going to put 480. And instead of m, I'm going to put 15. And instead of x, I'm going to put 10. And then I'm going to put my plus b because that's what I'm trying to figure out. Okay, now we're going to solve this. So we get 480 equals 150 plus b. Remember, when you multiply by 10, you can just add a 0. I'm going to then solve this by subtracting 150 from both sides. So my y-intercept has to equal, well, I pick up my calculator, 480 minus 150, and I get $330. So I make $330 a week, no matter what. So this table's equation would be y equals my slope of 15 times the number of phones I sell plus the $330 that I get just for showing up to work. So I know that this all looks like a lot of steps to do, but if you take it one step at a time, we do the loop-d's to find the constant, we plug into our equation, and then we write our pieces and parts. Okay, so let's practice with another table just to make sure we're kind of good with what we're doing. All right, so we have, let's skip this one because we've run out of room. Let's go ahead to this one. All right, we have x over y, and we have 1, 8, 2, 15, and 3, 22. Okay. All right, so let's take it one step at a time. First thing we have to do is we have to find the consistency. All right, so first thing we have to do is we have to find the consistency. So we're going to go ahead and we're going to loop-d it. All right, so 8 to 15 is plus 7, and 1 to 2 is plus 1. So we have 7 over 1. 15 to 22 is plus 7. 2 to 3 is plus 1, and we get 7 over 1. So our consistency is 7. For every 1x, it's 7 y's. All right, so now we have to find the y-intercept. All right, so I'm going to steal my information. So we're going to steal that m is 7 that we just got. All right, and then we're going to steal 1, 8 because, well, why not compete with 1? So we're going to start with my y equals mx plus b. My y value is 8. Stole it from there. My m value is 7. My x value is 1. So now 8 equals 7 plus b. So b has to equal 1. So the equation to this table is y equals 7x plus 1. And that means I can plug in this. So if I do 3 times 7, it's 21. 21 plus 1 is that 22. 2 times 7. So I can continue this table using this equation. Okay. There is one last format of our information. All right, and that is writing equations from graphs. Writing equations from graphs. All right, so in the next video, we're going to actually finish this then of writing equations from graphs and then add in the slope formula because they're all going to tie together.